Welcome to the Foresight online compliance software for Part L of the building regulations. A member of the website simply logs on. This gives the user access to their online administration page where they can design and store an unlimited number of projects. Let's start a new project. So the setup page, just put in assembly. I'm going to do it to near zero carbon. So the performance level is near zero carbon. The address we need to input the country, so it's Ireland, region, Ireland again. Dwelling type, call it A, and the number of dwelling types we'll say is 5. Dwelling description, property type, we'll say standard dwelling. Floors, first floor. Conservatory, no. Build form, semi-detached. Sheltered sides, 3. Basement, no. The method of construction, we have 3 methods. We'll use the full fill cavity method on this particular project. Intermediate floor, timber joist or concrete, we'll go with timber joist. Draft lobby, no. Window frame type, go for UPVC. Ground floor insulation above the slab. Y value option, we have 2 options. We can use the Irish ACDs or we can use bespoke details. So we'll go with the Irish ACDs. Opening head type, concrete. Living room area, 15. Roof design. We have 4 different roof types. Any combination of these 4 types can be used in the design. So in this particular project it's straightforward semi-detached, so we'll just go for a flat ceiling. No dormer, no story and a half, or no flat roof. Fixed building and renewable technologies. On this project we've decided to use an air source heat pump, so we don't require solar or PV because we have our renewable, so we'll say no to this option. Number of occupants, 3 to 5, and we have no heat source or secondary heat source. So we click on next. So we move to the next section of the calculator, which is the dimension input section. The software now collates the dimensions required by DEEP and the thermal bridge calculation in a standardized way. We simply click on the input box and we input the exposed ground floor length. We input the length of the party wall, internal walls, area floor slab, average story height, external corners. We have no internal corners and the number of party wall corners is 2, and we click on next, which is intermediate first floor. We input the exposed intermediate floor length, party wall length, internal walls, intermediate floor area, average story height, external corners, no internal corners, and party wall 2. Click on next. Flat ceiling, we have 12 meters of exposed eave, party wall 8, exposed wall and party wall 8, and flat ceiling area 64. Click on next. We've already dealt with corners. We now need to collate the opening sizes of for the different elevations. So let's go to the north elevation, which is the front elevation. This is a semi-detached, so it's 3 elevations, north, east and south. Click on next. So we need to input the width and height of the windows, doors, roof lights and hatches for each elevation. So I'll just put in very standard windows, just this exercise. North door. Click on next. The east elevation, so this is semi-detached, we'll just put 1 window in this elevation. Move on to the south elevation, and we put in similar windows to the front elevation. Put in the back door. So the dimensions required by DEEP and the thermal bridge calculation have been calculated. We now move into the design section, and we need to choose the structural material and the insulation materials for the floor, wall and roof. So you just simply click on that and choose the type of floor slab, subfloor. The software will automatically give a standard depth. Now that can be changed, and it's the same with the screed. That can be changed. You choose an insulation material for the floor, and the software will work out the depth. Click on next. Similar thing with the walls, the external finish. We have a sand cement render. We have an external block. Stick with Polytherm full fill insulation. We go with the internal leaf of block, and the software will work out the depth of insulated board and the main insulator. So click on next. Flat ceiling, choose the centers, the insulation between the rafters and the insulation over the rafters. Click on next. So our technology has calculated the Y value and designed a heat pump to suit the dwelling. This design approach reduces the energy demand of the dwelling by as much as 40%. This makes a B1 specification an A2 with no extra cost. This is because the Y value calculation is good detailing, which requires no extra labour or material, and although the heat pump is dearer than other boiler options, the other options don't reduce the energy demand. If a near zero carbon specification is required, the technology will run increasing depths of insulation for the floor, wall and roof through the calculator until cost-effective compliance is achieved with the performance level required. The software will only use the more expensive, higher performance windows if required, but it will never use air tightness of less than 5, because this requires more expensive heat recovery units. So basically, the software will design this particular dwelling to be cost effectively compliant with the performance level required.